Alright, so hey, everyone turn your attention to the sideboard here. I'd really appreciate that. If you look over Monday, the 4th of this month of March, okay? Lily, head up, please. Thank you. Okay. SWBA. Julia, what does SWBA stand for? Students will be able to use inverse trig functions to find measures of angles, which is section 8.6. We don't know what an inverse trig function is today yet, but we're going to learn it. And by the end of this lesson, we're going to learn it and be able to find angle measures.
Do I need a bird view?
Yeah.
Do I need a bird view? I got you.
Hold on.
I got it.
So, now, does anybody know what inverse operations mean in math? Okay, they mean opposite, right? They undo each other. So can somebody give me an example of two inverse operations? Paige, make sure that's away. Thank you. Okay, somebody give me an example of two inverse operations. William. Addition and subtraction. If you add and subtract by the same number, they undo each other. Nick. Multiplying and dividing. Very good. If you do that by the same number, they will undo each other. Anybody else have an example of inverse operation? There's more out there. The square root? Yep. What's it the inverse of?
Square.
Squaring something. It's the inverse of squaring something. So I'll put like an x squared so we see that something's being squared. Okay? So it's the inverse of squaring something. So square and square rooting are inverses. Very good. So they undo each other. And when we undo each other, we get what we originally had. When you undo something, you get what you originally had. Like if I go to Walmart and I buy something and it turns out I didn't need it, so I go return it, right? Are they going to give me $5 less than what I paid? No, that'd be a ripoff. What are they going to give me? The same amount, right? They're not going to give me more, they're not going to give me less, they're going to give me the same amount. And that's going to make it back to what it was before. It's going to give me the amount it was before. It's going to make it normal again. So that's the same idea with these inverse operations. When we take the inverse operations, they undo each other, and we're back to what we originally had. So the same thing is true for inverse trig functions. All of our trig functions are sine, cosine, tangent that we learned last week. We have inverse functions for those as well that will undo them and leave us with just the angle. So we take sine, cosine, and tangent of an angle. So this is how we get the angle by itself. So if sine of angle A is equal to x, then the inverse sine of x is equal to angle A.
What's that sign? Like,
It's pronounced inverse sine. I'll talk about that.
like what's the thing above it?
It's a -1.
Alright.
So it looks like sine to the power of -1, even though it's not. That's what it looks like. That's how it's written. But it's pronounced inverse sine. Yes, that just indicates that it's the inverse. So this -1, it's not like actually a power of -1. It's not an actual exponent that we're going to raise this to, and then we deal with negative exponent properties. We're not doing that. We're not doing that. Yeah, we're doing that now with 1 right now. We're not doing that. What this means is it's just saying this is inverse sine. It's a different function entirely called inverse sine. It undoes the sign. Now mathematically, how this works mathematically, I'll show it below here, is if we have sine of angle A is equal to x, you would take the inverse sine of both sides. And this gets a little bit big to write in here, so I'm going to write it above it just because of room. You'll take the inverse sine of both sides. Now this can be compared to if we have x squared is equal to, let's say 64 like we had earlier. What would we do to both sides? You would take the square root of both sides. Well, similarly here, we're taking the inverse sine of both sides. To get rid of the square, we take the square root. To get rid of the sine, we take the inverse sine. Same kind of concept here. So here, what happens with the square and square root? they undo each other and we're left with just x, right? So what do you think is going to happen with sine and inverse sine? They're going to undo each other. And we're just going to be left with angle A. And just like here, we're left with what's equal to the square root of 64, we're left with the inverse sine of x.
Should we write this?
I wanted you guys just to look at first, and then I'll have you write it in a second. Thanks for asking. So we'll be left with this, the inverse sine of x. And then, if we had a number in here, we would actually do that operation. I'll show you how in a second. Just like here, when we have a number here, what is the square root of 64? 8. So we would finish that off one more step. And if we had a number here, right now inside this parenthesis, we would show that. I want you guys to write this top part here. I want you to write this top part here. You don't have to write the squaring part.
Down here?
I want you to write the top part down here. You have a little bit of dead space below that tangent of angle A. I want you to write it right below that. That. I want you to write what's above that green. Above. No, that's just how it's written. That's just how it's written. That just means the inverse sign. We're not going to do anything like actually make the exponent positive or anything like that. We're not actually dealing with exponents. It's just how it's written. Yeah, it's just a label. Yeah. So now that we have that down, similarly, the inverse of sine is inverse sine. The inverse of cosine, if cosine of angle A is equal to x, if we want just angle A by itself, we'll have the inverse cosine of x is equal to angle A. The inverse cosine of x will be equal to angle A. So you take the inverse cosine of x there. Inverse cosine of whatever that number would be, which x is holding the place of, would be equal to our angle. So just like we took the inverse sine of both sides, we would take the inverse cosine and do the same process. And tangent of angle A is equal to x, then the inverse tangent of x is equal to angle A. Once again, this is pronounced inverse tangent. Don't say tangent to the negative first, it's inverse tangent. It's pronounced inverse tangent.
Oh.
Okay. Does anybody still need these three things up here? Okay, flip over your page. Hey, Alicia just made an observation. Alicia, what was your observation with our packet? It's our last page for our packet. If you flip it over after this, it's blank. This is our last page of the packet. So we're done with this chapter after this section. This is our last section of chapter 8 of dealing with right triangle trig. Okay? So, heads up, if we look over to the sideboard real quick and revisit it, today we're using inverse trig functions to find measures of angles. We just learned what inverse trig functions are. Now we're going to do that second part. Next, we'll be solving trig word problems and reviewing for our test, and we'll continue to review for our test, which will be on Monday.
Wait, Monday?
Oh,
I'm talking to my mom.
So, on example 1, if we're trying to find angle C, if sine of angle C is equal to 0.24, sine of angle C is equal to 0.24, we need to get C by itself. Now what I'm going to do is I'm going to write this up here again, just to give myself a little more room to work with, just because inverse sine can be a lot to write there. So I'm just going to give myself a little bit more room to work with. That's the only reason I'm rewriting it. I didn't do anything yet, just rewrote this problem. It might be a good idea, yep, just write it off the side, just give yourself some space. Yep, sine of angle C, I just wrote exactly what's right here. I just wrote exactly what's right above my pen right now. Okay, so now we want to get angle C by itself, so we have to undo the sign, and how do we undo the sign, Nathan? Take the inverse sign, make sure we're, being careful about that, of both sides. We'll take the inverse sign of both sides. Now, we wouldn't take the inverse cosine, would we? No. That'd be weird because we're doing with sine. So because we're dealing with sine, we'll take the inverse sine. So what do the inverse sine and sine do to each other? They cancel each other out, they undo. What are we left with on this left side? Just angle C, which is what we want. And now it's going to be equal to the inverse sine of 0.24. The inverse sine of 0.24. So, if everyone has one of my scientific calculators now, that'd be awesome. If you don't, please raise your hand so I can get you one. If you don't have one of my scientific calculators, please raise your hand so I can get you one. And if you look right above that button where we pushed sine before, right above that button where we pushed sine before. Everybody have one of my calculators now? Okay.
No.
Alright. So what we're gonna do is, if you look right above sine, if you look right above the sine button in that small font, what do you guys see? You guys see the inverse sine there? If you look right above the sine button in that small blue font, do you see the inverse sine button?
Yes.
Yeah, so what you'll do is you'll push second up in the very top left corner of your calculator, push second, and then you'll tap the sine button, which will get you to inverse sine. So what should pop up in your calculator right now is sine as inverse sine like that with a parentheses. So that should pop up in your calculator. Does anybody not have that in your calculator right now? Okay.
What is this?
Follow. Okay. Well, exit that. Okay.
I got
So
no.
because you entered it in wrong.
Oh.
So everyone make sure we're at this point. Okay, is anybody not at this point with me? Okay. You are? Okay. Okay, so then what are we gonna put in this parenthesis? 0.24. Close it and push enter.
I put 24.
Close it and push enter.
13.
Okay, so this will be a decimal here, but let's round it to the nearest whole number.
14.
Okay, so it ends up being angle C, the measure of angle C ends up being about 14 degrees. It's an angle, so don't forget we measure angles in degrees. Measure angles in degrees.
You are?
Okay,
Is that 0.24?
0.24. You have has to be 0.24. Okay, it won't work if you just type in 24. Okay, so 0.24. And so we take the inverse sine of that, like we had here, and measure of angle C ends up being approximately 14 degrees. It rounds up to that. So we had to do the inverse because we had to get the angle by itself. So kind of if we go back to our original setup here, we had sine of angle C is equal to 0.24. We need angle C. So we need to undo the sign. And it's not division because it's not multiplying. Sine isn't multiplying with C. We're taking the sign of it. Just like if you have something x being squared, you don't divide by 2 because you're not multiplying. You square root. So just like here, we're taking the sign, we have to undo it by taking the inverse sign. Let's look at letter B here. I want you guys to try and do letter B on your own. I want you guys to try and do letter B on your own. Go ahead and try and do letter B on your own. Once you're done, please raise your hand so I can check it or someone else can check it. Or once you have questions, please raise your hand.
Oh, yeah.
And let's round to the nearest whole degree. Let's round to the nearest whole degree, okay? Yeah. Okay, go ahead, check.
I got
Go ahead, check. Okay.
You put root to me. Okay. I agree. Oh, I got it.
Abby, you want to help check?
Are they,
You get it right? You get your answer? Has it checked?
I got it.
Raise your hand.
This is too easy.
Huh?
Oh, I got it. Oh, my bad.
I'll show you guys.
That's what I want to win on. Can't fall asleep there.
When did you get it? Yep. That's right. So just the nearest degree from that. Next
don't know if I did this right.
Yeah, you got it right. You got it.
Oh, yeah.
So far, so good. Bring on.
Go ahead, check this out before you write this down.
Right, 60 degrees. There you go.
Dude, tissues in here?
I'm out right now. I just ran out. Yes, very good. Hard
I thought
knocks.
this part. I thought it was putting in the answer. I thought it was
You want so bad? I need a tissue.
Use your sleeve.
No, I'm not using my sleeve. I'm using a piece of paper.
Okay. Don't turn it into me.
I will turn it into one t-shirt about life.
Oh, I mean, you like.
I was gonna say.
Ready?
Oh.
What is this? Here, buddy.
Okay. So let's bring your attention back up here. Let's bring your attention back up here. So if we have cosine of angle C is equal to 0.37, how do we get angle C by itself? How do we get angle C by itself here?
Get rid of, use opposite inverse cos.
We have to take the inverse cosine of both sides. Take the inverse cosine of both sides. Because the inverse cosine of cosine undo each other. So we just get angle C is equal to the inverse cosine of 0.37. Yep, second cosine, 0.37, close parenthesis, and we get the measure of angle C to be approximately 68 degrees. The nearest whole degree and the being about 68 degrees. Now, I got to ask the question, hey, Mr. Hassel, how do we do this on our calculator, okay? Android, exactly as done here, or Scientific. iPhone, how you would do it is you would type in 0.37, and then I believe there is a, can you give me your calculator? You go to, you type in 0.37, and there should be a second button. There's a second button almost all the way to the left. All the way to the left, right below the parentheses, there's a second button. On your right, and you turn it to the left. Okay, no, okay, no, alright now. So, if everyone has an iPhone calculator and wants to know this step, this is how. You type in 0.37, not right now. Nope. Okay. I can teach you later. Okay. Thank you. So, guys, voice is off. Thank you. You push the second button. You push the second button here, and it pops up inverse cosine in the place where cosine was. So you tap that, and you end up getting the same thing. So very similar to how we would have done it. Okay, you also can use the Desmos calculator online. You can Google Desmos calculator. That's a good one to use as well online.
I have a question.
What? I've never heard that one, but maybe.
I have a
It
question.
tells you all the answers.
Oh, okay. So
What's
cheating.
sine H?
Hyperbolic sine, but we won't talk about those.
Oh, is that
That's a trigonometry concept. Yep. Yep. You go to hyperbolic trig functions. Okay. So we're gonna need it right now. So let's look at example 2. So here we're supposed to find angle Q to the nearest tenth of a degree. We have two sides, and first of all, I need to tell you this is a right triangle. Tell me I need to tell you that's a right triangle. We have angle Q, or we need to find angle Q, excuse me. This is the angle we're trying to find. I'm going to circle that. And one thing we can put in there is we can call it theta if we wanted. That's a variable we use for that. Or we can just call it angle Q. Either way is okay with me. We can either call it theta or angle Q. Either way is fine. So, because that's a variable for an angle measure. We're trying to find the angle measure. So, thank you. So, we're almost done with this, guys. Thank you. So here, from angle Q, we say, okay, from our sides, we're going to form a trig function. From angle Q, what side are we given right here where my pen's at? And what side would that be from the angle? The adjacent, very good. And what other side are we given? The hypotenuse. So which trig functions involves adjacent and hypotenuse? Cosine, COS. Make sure we're pronouncing it cosine. Cosine of angle Q is equal to what over what? 8 over 15, very good, Carly. Adjacent over hypotenuse, 8 over 15. So this is how we set it up, similarly to how we set it up before, except now our unknown is our angle measure, where before our unknown was one of our side lengths. So we say, okay, well, how do we get the angle by itself? How do we undo cosine? Inverse cosine of both sides. This time we just take the inverse cosine of this whole fraction. You could divide it first if you wanted, otherwise we can take it to the whole fraction. If you divide it first, make sure you have the decimal out to 4 decimal places if it goes that far. So we'll just have angle Q, because inverse cosine and cosine undo each other, is equal to the inverse cosine of 8 over 15. On a calculator, what you would do is you type in inverse cosine, so that second cosine, you have the parenthesis open up, you type in 8 divided by 15, close your parenthesis. Type in 8 divided by 15, and close your parenthesis after the inverse cosine. Yep. Yep, which is the number we're doing, the fraction we're doing. Okay? And let's round it to the nearest tenth of a degree on this one. Nearest tenth of a degree is what it's asking us.
57.
Yes. So the measure of angle Q ends up being approximately 57.8 degrees. Did anybody not get that so I can help you out? Anybody not get that so I can help you out?
I didn't get it, but I figured out what I did.
Okay.
I put sine instead.
It was 50, it's 50. I didn't get that. I have to get it.
You're not so rounded.
Oh, man.
There you go.
No.
I'm glad you did.
Here's 10.
So you have to do is you have to first divided by 15. And then take second.
Oh, okay.
So on the phone, what you'd have to do, on an iPhone, what you'd have to do is you first have to divide 8 divided by 15, and then do second cosine, which would give you inverse cosine. So on a phone, you'd have to do the fraction first, and then take the inverse cosine of that, because you type in the number first on the phone, on the iPhone. Questions on example 2? Okay, let's look at example 3 right now, please and thank you. A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? Well, first of all, what are we going to probably have to do? Draw a picture, okay? I want you guys to try hypothesizing what your picture would do. I want you guys to try and practice drawing a picture and kind of see how this would look. So try drawing your picture and maybe comparing it to others around you. So draw your picture, take a second, draw your own picture, and then in a few seconds here I'll tell you to compare it to those around you. So draw your own picture for this, of what this would be. We're working on interpreting that word problem, so draw your picture. Maybe sketch it a little lightly just to make sure, before you're doing it like really hard. What shape are we probably going to end up making? We're probably going to make a right triangle, so that's probably a hint. Oh, it will be a right triangle.
When is
Well,
this
I
gonna?
got it right. Wait. That's my road.
That doesn't make any sense to me. Yeah.
Wait, I have to draw my
Why you
line.
make that?
I like triangle.
I don't know if this is right.
I know what to do.
We're setting up a word problem. And what is everything? What have we done? What shape have we dealt with this chapter?
You put your
I don't see why we do that.
I don't know.
Okay. So Randall, what shape have we dealt with this chapter?
Does this look good?
What kind of triangles?
Does this look good?
I don't know.
Right triangles. The whole chapter we dealt with right triangles. So we're gonna keep working with them.
That doesn't make
One
sense.
less example.
That doesn't make any sense.
Why do we deal with a right
You
triangle?
guys actually do a picture.
What doesn't make any sense? Randall? Don't just say
Why
that.
are we making a right?
Why are we making a right triangle? Because in this problem,
Oh, I just did.
we'll have to
I'm not
make
gonna
a
ask
triangle,
questions.
we'll have to make a shape
Why do you
of
have a
some
band-aid
sort.
on your face?
And what shape have we dealt with this entire chapter?
That's true line.
You know,
Okay, but
wearing
what
a
shape have we dealt
band-aid
with
just
this
makes
entire
you want to
chapter?
ask questions more than having give
There's no point to a third
Yeah,
line.
that's awesome.
Yeah, nobody
What do you mean
cares.
the
Everyone's
fourth
And
asking.
that's the line. 200.
It's on your side of the bed.
But there will be a line.
Where?
What shape have we dealt
Where's
with?
the shiny?
I know.
The whole thing inside right triangle.
I'm saying, I don't understand that.
Where
Whoa.
in this picture,
I don't understand why.
Calm down.
in this one specifically, or in general,
That's so gross. Oh, Band-Aids on his bruises.
are you saying you
It's
understand what this
200 over here.
this problem, or in general?
I don't understand why we're even thinking of it.
Well, the one that we can constantly use, what shape
Right
is
on the
that?
bottom. Did you?
No, it's just why we're doing.
I don't know.
Well, that
All this hypothesis we just don't.
Yeah. No, like for yourself. Oh. Right? Mr. Costle's so strong.
We'll talk about this. So,
You guys did it.
so I want you to share with the partner next to you. Share with the partner next to you. Compare kind of what you did. Compare what you did with the partner next to you. Compare what you did with somebody next to you.
I don't. I keep trying.
Well,
She did it my way too.
yeah, see, how many times are making sense?
She's with us.
Guys.
Daddy.
Mr. Costle, look at my shoe. Oh.
You know, yeah, two, back, two.
I don't know what happened.
Here.
No,
I'm sorry that happened to your shoe.
When? I'll clean it, I know how. I got mud on it and I cleaned it up perfectly.
Did you put my pencil back?
Grace, you wanna clean mine?
Hey, I'll clean your
Stole
shoes.
it.
You took back my shoe. You took back the shoe.
Yeah, 'cause I went to the bathroom.
I'm serious.
Hey,
Hey.
Oh, the pencil's right here.
Tracy, wanna clean my shoes?
I hate
I'll pay you.
so
I'll pay you.
voices back off, attention back up here, please and thank you. We're almost done with this example and almost done with this note packet. So, a road rises 10 feet in a horizontal distance of 200 feet. And what is the angle of inclination? Well, first of all, what shape are we probably going to make?
Triangle.
Probably a right triangle. So a triangle with a 90-degree angle. That's what we've been doing the whole chapter. So it makes sense that we wouldn't change it now. We probably wouldn't throw in a circle or a square if we've been dealing with right triangles the whole time. Let's continue doing right triangles here.
You're dumb. He's right
That
there.
way. Okay.
He's right there.
So the road rises 10 feet in a horizontal distance of 200 feet. What's horizontal mean?
Sideways.
Straight left and right. So we know there's going to be a straight left and right length. And how long is the straight left and right length? The horizontal.
200.
200. The horizontal distance of 200 feet. So we know this is 200 feet.
Okay, we're wrong.
If it's so we know there's a horizontal distance of 200 feet in there. What's it say about the 10 feet? What's that doing? It's rising. So it's going to go up. It's going to go up. It's going to rise straight up. It's going to rise straight up. So what kind of angle is this going to make?
Why'd you do all that?
Yeah, wouldn't the road go up?
It could be on either side.
I did it that
Okay.
way.
So you could have the 10 over here. It'd be fine.
What if they said the 200 go up?
It's not. It's neither wrong nor right. Okay. Nick, what's your question?
Actually, it's common. If you think about it, it's also a decline the other way.
It would be a decline the other way, yeah. But the way we're looking at it, it would be an incline. And we'll talk about that actually. We'll talk about that. So, what kind of angle would this horizontal make with the vertical? What kind of angle would that make? A right angle. And what's going to be connecting these two? If I draw this, if I keep going this out here, the hypotenuse, which is our road. This is our road right here. Okay.
Looks like
Look
a
at that.
burrito.
Look at that perfect drawing. Looks like a Dorito.
Yeah.
Here we go. Okay, nacho cheese flavor.
Do you know those ones that have like the variety has like sun chips?
Mm.
Yeah, it looks like those ones. Those like look like Doritos.
Okay. So here we're trying to find the angle of inclination. So after we do this, we said, okay, it's horizontal distance of 200 feet, horizontal 200 feet, rises 10 feet, 10 feet. The road rises this much in a distance of this much. It's kind of like a slope. The angle of inclination, we said we had an angle of inclination or elevation and an angle of depression. Angle of inclination means it goes what way? Up or down? Up. Incline, going up. Okay? That's in reference to a horizontal angle. It has to be in reference to a horizontal angle. You couldn't have it like in reference like this because we don't know if it's going up or down. It really could be either depending on what you're looking. Well, if it's from a horizontal, Randall, please look at me. If it's from a horizontal, you know, oh, it's going up from a horizontal. Or now it's going down from a horizontal. So, where would this angle of inclination be from the horizontal going up? Where would the angle of inclination that we're trying to find be from the horizontal going up? Which one? The bottom one to the left is the angle we're looking for. That's the theta that we're looking for. So, Abby noticed something, or excuse me, Carly noticed. I think that's the first time I've done it all year. Well, I wouldn't say that, but
You
anyway.
said that last
So-
time. You did it last time too. Yeah.
You call Nathan Nate. You call me and Nick the wrong names all the time.
Like 3 times in one class.
Yeah, in like 10 minutes.
Yeah, it was bad. I've done them pretty well. Okay. So
I know the answer.
from tangent, what side is this 10 feet?
It's the opposite.
From 200 feet is the adjacent. So which one deals with both opposite and adjacent, Carly? Tangent.
Good.
So our TOA, what?
You already said that.
Yes, I'm just going through it right now. So tangent of theta, our unknown angle, tangent of theta, sure you can put x in there. Okay. Tangent of theta, I don't know if you want to bet, but okay, is equal to what over what? 10 over 200, opposite over adjacent. Now how do we get theta by itself if we're looking for this angle, William?
Inverse of tangent.
You take the inverse tangent. You take the inverse tangent of both sides. Now the inverse tangent and the tangent undo each other, so what are we left with on this left side? Just theta or x, whatever our variable is we called it, is equal to the inverse tangent of 10 over 200.
Question.
Answer.
Why do you put the tan over the equal sign and not next to the thing?
Because am I going to be able to fit all of this right here
No, like on the other side.
on the other side? Because we always write it in front of it because that's how we write that we're taking the inverse tangent of it. Good question. So Gracie asked, hey, Mr. Carl, so why don't you just put like 10 over 200 and just say that this is the inverse tangent? Because we always have to put the inverse tangent or tangent or trig function or inverse trig function before whatever we put. So this means this would be 10 over 200 times whatever we're taking the inverse tangent of. So right now this means this is multiplying with this. Whereas if we write it beforehand, it means it's taking the inverse tangent of it. So that's why we have to put it in front of it in order to be taking it of it.
I'm gonna look up the scientific calculator.
Right. Desmos is a good one. Yeah.
When we do it on our phone calculator, so do you have to divide 10 by 200 and then you write that number
Yes.
and no? Okay.
Or you can just do the inverse tangent of it from there. You don't have to write it down. Yes.
At this point, are you able to simplify?
Yeah, at this point you could simplify. You could just say you could simplify to 1 over 20. Is that what you're thinking, or you put it in your calculator? So you could simplify to 1 over 20 in this fraction if you notice that. That's perfectly fine to do. You'll get the same answer either way. So if we take the inverse tangent of 10 over 200 or 1 over 20, what do we end up getting to the nearest whole degree?
26.6.
3 degrees or 2.9 degrees.
Oh, you said that.
Do you want to hold on? I didn't do that right.
How do you know when you want?
How'd you put it?
It'll specify on there. It'll specify on there.
Changed it to 3.
Second.
10
And
over 200. You get 20. You wrote 20.
Somebody go home.
Okay. So let's just look at this one more way here. Let's just look at one more thing just to verify if this makes sense. We want to say, is our answer reasonable? Well, which of these two legs is bigger? 200 is quite a bit bigger than 10, right? So if this is the shorter of the two legs, the smaller of the two legs, does that mean its angle is going to be smaller than the other one? Yeah. So is 3 going to be smaller than what the other one has to be? Yeah. And that is quite a bit smaller in length, so it makes sense it's going to be quite a bit smaller in the actual angle measure itself. Questions on this?
no.
Kylie, you're kind of getting it.
Yeah, it's like
Desmos, yep.
No, we got saved.
Okay. Thank you, I appreciate that.
Yeah, Carly, when do you
Okay. So let's have our voices off real quick as they pass this out. Okay. So. Yeah, those are all those. Okay. So, Paige, I'm gonna pass yours back to this row. This is what it's easier on. Set up. Okay. So this worksheet, 12 problems. When is this one going to be due? Wednesday, my dudes, okay? Wednesday, my dudes, beginning of class. Hey, let's make sure that we use this time wisely right now. We have about 12 minutes before our class is over. Let's use this time wisely and get a head start on this, okay? You guys can feel free to put music in, that's fine. Put music in, listen to music, that's okay. Encourage if you want it to. I mean, I usually listen to music when I work on stuff, okay? So, we're gonna now, so that way if you have questions, you can ask me in Mrs. Haswell while we're here.
I have a question.
Yeah.
No.
What's up?
You have these made out of change to X.
We can change the text.
So what's the 0 to me?
You don't have to be a math class around for a while.
Well, I'm just gonna change the X every time.
Okay. Other teachers might not let you heads up.
YOLO.
Okay. Suppose that is true.
You didn't hear that, did you? Sorry.
Profanity, please. I'm a Christian child.
Yeah.